Hi, everyone. If you don't know me, I'm Andrew McPherson. I'm a student here in Chattanooga until May. I'm going to graduate, and I have no idea what I'm doing. But until then, I like to mess around and make games. It's a little hobby of mine. And recently, I started working at Bellhops, and those guys are awesome. They're using React.js, and I thought, I can use this to make games. More on that later, but React.js is not meant for game development, but we can misuse it as such. A lot of what I'm going to be discussing today is how do you build web games. And there's a ton of tutorials to build web games, but most people use Canvas. Most people draw and render and those sort of things, and we'll discuss that further. But if you have any questions, please save them to the end, and I'd love to hear any feedback you have. So, awesome. Let's begin. So traditionally, we use sprites in our game development. In 2D games, we have a flat surface that we render things on using our graphics programming language, and a sprite is any individual component that makes up the scene. For Mario, that would be the plumber himself and the mushroom. And when you put this together, you get the scene. But the way this would go traditionally is that we would have a whole bunch of different sprites, be it the blocks or the pipe or the plumber or the mushroom, and we'd render them over and over and over again. We would wipe the screen, we would draw out everything, and then we would wipe it again, and we'd draw everything, and we'd wipe it again, and we'd draw everything. This is mostly because we'd have a game loop that would be going through and listening for input from the users. And whenever something changed in the model, then they'd update the view. And this was the view. And this is how they did it. They did it over and over. And if you're good, you'd do it at 60 frames per second. You'd be doing it constantly, just letting your CPU buzz through it. And that's not always the best, especially from programming perspective, from us as like developers. It's a total pain to have to mock up everything so that we're writing it every single time, especially in a game of Tetris, for example, where very little on the screen changes, but we're completely wiping it every single time. Like here, the tetromino is the only thing moving. This thing here. Only way it finally reaches the bottom does the well get cleared and actually all those things change. But instead, we're just re-rendering it over and over and over and over. And sometimes the tetromino, if it's really slow, if you're like on the first level, it takes a couple ticks for it to fall. And so that's a whole bunch of frames that are just exactly the same. And people optimize these kind of things. They look at what changes, and you get some dead pixel bugs, and you try to erase only what's been changed and what's not. And it's kind of a pain as developers to try to think through that as we're rendering it. So I think it's really neat that we have things like HTML and XML, which are entirely for structuring these kind of things, and we can use React to speed this up. More on that later. There has to be a better way. What could it be? It's React, or the DOM specifically, rendering into the DOM, not onto an XML, not onto a canvas element, like we traditionally did in all of our old programming. If we're on the web, why are we making a whole section of our page be where we're rendering the game when we could actually just be using all the native DOM, HTML things that are built into the browser? The browser's made to make things, to output what things look like. That's what it's for. I think it's really funny that when we decided to start making games in the browser for web games, we had decided to make an entire HTML5 element called the canvas that we just do our traditional re-rendering stuff on, when we could just be using XML. So if you don't know what DOM is, it's a document object model. HTML, XML, and SVGs all use this idea, and it's kind of the way that JavaScript traverses or manipulates those HTML, XML, SVG elements. It's a tree-like structure, and you can crawl it, you can traverse it, you can change it. And the DOM is what represents the page. So this is an unusual HTML page. I stole this from Mozilla's developer network, but it looks familiar. There's a root, which is the document, and everything kind of flows down from there. So React is really neat, and I really love it. And what it lets us do is harness that power of the DOM in the JavaScript. If you don't know what React is, it's a Facebook built and used framework, and they support it, but a lot of other people use it. It's open source now, which is really neat. It's a JavaScript framework, and in the MVC continuum, it's only the V. It just does the view. It just does output. A lot of my talk today is not going to be going into nitty-gritty about how you would totally make a game in the browser. I'm just talking about the output, the rendering, using React, which I think is really neat. React is really cool, and I love it for a ton of reasons, but particularly because it only ever re-renders when something's actually changed. So in that Tetris example, if we had each of those different things be a different part of the DOM, a bit different like box or div, if the tetromino fell, the browser using React would recognize that only that fell and only update that part of the page. You wouldn't have to go through and re-render everything. Likewise, it tightly couples your markup and your scripts, which is really neat because a lot of the time when you're doing jQuery, you kind of have to like figure out whether that ID is on the page. You can have to set it up, and adding things through jQuery kind of looks ugly and weird. If you want to make a whole bunch of different pieces like that, it gets a little troublesome. So it tightly couples your HTML and your JavaScript. Is it good? Is it bad? I don't know. I like it. It's neat. The best part about React, though, is it's not comprehensive. It just does one thing really well. I think I was in here a while ago talking about Meteor, and I really liked Meteor. And I still do, but my biggest issue with it is that it's very comprehensive. It ships a whole bunch of different things with it. React is just one part. It just does the view. So you can use it for whatever, which is why I'm able to misuse it to build games. But still, JavaScript, the JSX format, which is really weird in React, is kind of odd and looks a bit weird when you look at it. So I'm running up some code here. You can import React. I'm using Browserify. But you create these classes, and you return actual HTML in the JavaScript. What's that doing there? What? JS Hint throws a fit, let me tell you. But regardless, what this does is that after you run this through like a compilation process, it converts it into code that looks and can be run by the browser. But what's really neat is that you can actually put the HTML in the code. So here's what the actual compiled code looks like, I think. Nah, I didn't put that in there. But you can create subclasses as well. You can just find a whole bunch of different classes. So I made a game in that last section. I'm now creating a new class called Message. And every class in React has a render function. They'll throw an error if you don't. And what happens is that when this happens, they call the render function. So here I'm just going to write out a div. And that updates the screen. What's really cool about defining these different classes is that you can actually repeat them over and over. They're like cookie cutters. So if you have a reusable piece in your web app, you can just copy and paste it a whole bunch. So here I use the message a whole ton. React is also really neat. It exposes external properties, like properties in HTML. So you can actually create your own little API for how you use each of the different things. Here I'm adding a property to the message that I just created, so that instead of just always saying all your base belong to us, it just prints out what's been prompted to print. So it's really neat because now you're kind of creating your own HTML elements. You get to use them how you want. So you can also put the CSS inside your React elements. It makes it kind of inline, so now you're also coupling your CSS with your HTML, which may not be the best practice, but for the game development stuff I'm doing later and you kind of want to make it dynamic, it's always really interesting. So here I'm creating a ball called the Pong ball. And here you can do styles just as like a JSON object. And if you pass that to the div here, style equals style, you can actually render it using that way. So I made a little ball there. So what we're doing, just to summarize, is we're creating classes, and we're instantiating them, and we can pass in properties, and we can pass in styles. JavaScript, React as a framework isn't too complex. They just have a couple little things you have to have that have gotchas. You can position the element absolutely like you would in CSS. And when I do game development using React, this is all I do. I'm positioning absolutely things on the screen. If you guys are familiar with CSS, you have the normal flow, and then you have the absolute flow. And you can position things by left and top, which is like it's X and Y, as I'm familiar with in game development. So here I'm positioning it 10 EMs over and 10 EMs down. Yeah. We can use state variables, which are like properties, but are inherent to each of the individual components. So here I'm saying instead of just writing in 10 and 10, I'm actually put it in a state variable, which is inside this React component. So if I were to have a separate Pong ball, it would also be separate. So if you are used to object-oriented programming, this is the idea of encapsulation. Each one has their own different attribute. So here I gave it a pixel value, 125, 175. I'm changing it to show you that I can change the position of the ball on the screen, which is the big ta-da when I want to actually make things move on the screen. I'm adding a loop. In the life cycle of React, you have the render, which happens every time something in the state or the properties change. And the component did mount only happens the very first time it's created. So here I'm making a loop function happening over and over. I'm just showing you guys that I have this loop utility. The tick is how long it's been since the last frame. This is using the request animation frame. And what I'm finally going to do to conclude is I'm going to set this state variable that I have up here to a value. I'm just increasing it by 32 pixels every tick. And what we'll do after all that work is let the ball move. Yeah! So just to show you what that's done there, by setting the state, it's required it to re-render. And so the ball here, this value changed, and it was rendered with a different style. And because of that, that's why the ball is moving. So it's really neat. You can have a lot of different things with an internal state that are all going about their own business, like you would have in a different game. You would have your monsters with their own state, and you're here with their own state, and they would all be re-rendering depending on when they need to re-render. To make it more like Pong, I did also add velocity. So this would make them move in a direction dependent on the state. So I'm just saying 32 pixels every tick, so I'm just replacing that hard code value, which is also useful because then I can add collision. So I can say if it ever reaches the bottom of the screen or the side of the screen, flip the velocity so it bounces around. Again, I'm not going to get too much into the nitty-gritty about actually making a comprehensive game. I'm just talking about the rendering engine through React. Giving you a brief introduction to React through that. I just did a whole mind dump of you guys of the different React syntax, but that's it. There's nothing more than that. I got bouncing, hey! So, React is really fun, and I like it a lot. Again, I'm not going to go any farther. That's as much Pong as I'm going to have. I made a whole bunch of different Pong balls with random position and velocity just bouncing around now. And if I wanted to make this an actual game, you would have to go through the process of adding paddles and user input and output, handling all that model so that the position of the paddles are known by the position of the Pong ball so they know when to bounce accordingly. I'd have to add win and lose stuff. There's a whole bunch of hassle. I don't have enough time to go into that. But if you're interested, come talk with me afterwards. Anyway, I want to talk about some of the cool things instead that you can do with React. By using this DOM model instead of the canvas idea of constantly re-rendering, you get a lot of different perks. One of them is that it's fast. Stupid fast. Super fast. It uses the shadow DOM, if you guys are acquainted with that, where it creates a model in the browser of the DOM, and so it can compare the two DOMs. Whenever you change something, it can look at what's actually just been changed and only re-render that. Because the actual re-rendering to the screen is the complicated part, right? By having that shadow DOM of what it used to look like and then React generating a new one and comparing it to that, it can create really cool fast things. How fast? I don't know. I made a game. It's called Who Am I? The entire point was just to hit the other players and then they're dead. There's nothing complicated. However, I put you in a room of identical NPCs with random AI, and you don't know which one's the other player and which one are just the NPCs. You don't even know which one you are. That's half the challenge, just figuring out which one you are. Each of these individual characters are like the Pong balls. They're in a own encapsulated class, and they're all moving on their own little loop AI thing. This is just kind of move for a couple pixels. They stop. They move for a couple pixels. Nothing complicated. But I wanted to see how many of these guys I could get on the screen before it starts slowing down. And this is on my dumb little laptop, nothing powerful. I got 756. 756 of these little bastards running around. So it can scale. It'll scale. The DOM is also hierarchical, which is also nice. You can do a lot of really cool things when you have all the different elements separated in the DOM. One of the cool things are cameras. So here's a little platformer I'd created. All these things are different DOM elements, but the screen's not following it. Just by adding some code around the thing, I created this camera class. This.props.children just says whatever's inside of it, inside the actual HTML element as you render it in the JSX, are just plopped there. So it's completely agnostic about what's inside of it. All this one does is that it gets the players X and Y. It gets halfway to the screen, so they're always in the center, and it does a negative of it. So if I'm walking here, the entire world that's around that guy, which he's positioning absolute, that's his parent, so he moves in relative to that. I move that entire world around with him, and that way he's always in the center of the screen. He never leaves the screen. So that looks like this. So he's always in the center of the screen and always follows him, which is nice. Yeah. So all it's doing is it's moving things so those things are all going off the screen to the left and the right. You can also get really clever if you wanted to. This is a camera where instead of following to the exact center, I get the players X and Y, and I divide it by the width of the screen, and I floor it. So if he's like 15 pixels inside my screen is 12, it's going to have 1 after I floor it. I times it by the width again, and do the -1. And what this will do is it actually makes it scroll on a granularity of room by room. So this one only moves when you hit the side of the screen instead of constantly while following you. You can also get really clever, and all the XML elements are, so you don't even have just boxes walking around. If I wanted to have a sword, I make it a child of my hero, and it'll follow the hero. Here's a ragdoll you can do, where which I thought was pretty funny. I was trying so hard to get Box 2D to like ragdoll it, but I couldn't figure it out. It just kind of fell on the ground constantly. But yeah, all those things are exposed to you through the DOM, and the hierarchy makes it really cool. You can do a lot of little clever things that you wouldn't necessarily otherwise be able to do if you're just doing it straight up in the canvas. The DOM is also responsive, which is really nice. We're doing web games here, and so you kind of want to harness all the responsivity that they have in the screen. So this is a game I had written, which was a Bomberman clone. It was nothing special, but when I first built it, it wouldn't respond to different screen sizes. And we were putting this onto an arcade cabinet, which had a much larger screen than mine was, so I didn't design it to scale. So wouldn't it be nice? Wouldn't it be nice if we could use media queries to do that? Yes. So I wrote this Sass plugin, and what this will allow us to do is respond to the screen size accordingly. So couldn't do that with your canvas. Your canvas would get all fuzzy. We can use SVGs as well. This is my quote-unquote sprite sheet. All these SVGs are different DOM elements. When you render them into a canvas, they would become raster, but because they're still vector, I can just use SVGs as I would. I'm using background size and background position here so I can get which particular monkey in my sprite sheet I wanted. So yeah, now it works on tiny little iPads as well as my big arcade cabinet. The DOM is also animated. If you wanted to do it in Canvas, you would have to like do all the tweening yourself. And if you guys don't know what tweening is, it's the idea of in-betweening. So if I had position here and position here, you'd have to run it through the Belvier curve yourself and not have to do math and stuff. But hey, CSS has that built in. So I can just give it an X and a Y and give it a transition element. These transitions look like this. So you say transition duration and property. Whenever top and left change, which is what I'm editing, depending on the player state in X and Y, animate it using this duration property. By default, it's linear, but you can add a whole bunch of different prepackaged CSS animation things as well. You can get really clever too. Here's a point-and-click adventure game that one of my students were making, and it's so boring. It's just panning. But what will happen if we animated it? So here we add transitions, and now it like has parallax. It looks so cool and smooth. Man, couldn't do that with your canvases. And the DOM is also dev-friendly, which I really like because I'm a dev. So you can use the web tools because each of these individual things are DOM elements. You can right-click it. You can edit their properties. You can see what properties they currently have. You can mess around with it. You can add debug things. All the Chrome web tools are completely exposed to you. They're not just a flat thing on a screen, one huge element in the browser's mind. They're all different things that you can mess around with. And also because you now have a formalized system for outputting everything, you can also write tests that would define how you expect the different things to move. This was really difficult because games have a ton of side effects. And traditionally, you would use like a whole QA department. And you'd have them in a dark room playing your game over and over and over and over. That's how the game industry has always done it. But writing tests, I think, is something that web development has figured out pretty well, but game development hasn't. But you can do that. React comes with a built-in jest system. So yeah, building games in React is a ton of fun. I really like it. And there's a ton of different ways to do it. It's not the comprehensive ipso facto way to do it, but I think it's really neat to start using React to build things in the DOM instead of just on a canvas. The browsers are optimized for this. Like, why are we going against them to do that? So yeah, thank you so much for coming. You can follow me on Twitter and GitHub at @goodenough, and I have a blog all about the games I'm making at YeahGoodenough. I'm just taking the summer off, and I'm just going to build games. So if you want to see GIFs of all my dumb bugs I have, YeahGoodenough.tumblr.com. But yeah, I'm giving this talk next week in North Carolina, and I'm super nervous. I'm going to the East Coast Game Developers Conference. I'm going, there's me. That's me. That's my picture. What's it doing there? It's because I'm speaking. So if you guys have any feedback, I'd really appreciate it. If I talk too fast, or I wanted too much, or if I beat up on Canvas, just tell me, and I will listen. Until then, thank you so much. Any questions? I'd love to hear them.